Milo wasn't at Phoenix last year, so he doesn't quite know like how I taught. So your 511 should be out, and it's real funny. Now, if you're still like up at number 1 or number 2, that's fine. But it's real funny that about 6 different times, and I forget who was working with me. I think it was somebody in the 3B class. But they were with me for almost all extensions. And over and over and over again, people came up to ask questions about this part of this paper. This part of this paper is not your homework. We talked about this yesterday. Now, I didn't record yesterday because I forgot, so I don't have a video to go back and say I told you so. But I promise you, Scouts Honor, which I take very seriously, I have an eagle tattooed on my back, so if you want to talk about what I take seriously, I drew an arrow here and said, you might want to make a note, put a star, do something to indicate this is where your practice work starts. This part up here is examples from class, and if we don't get to it, it just doesn't need done. It's just classwork. Now, not always. I was about to say always, but like later in the week, you might have a handout that is just all practice work, and from the top of it, it'll say this is your practice work. But your practice work always starts wherever in all capital letters, it says this is your practice work, and then goes beyond that, right? Now, with CPM practice, which was, okay, in Math 7, I will probably need to ask, like, did everyone use CPM last year? But, like, in your class, you're the accelerated class, I don't know how they could have done accelerated without using CPM. So one thing we got to talk about is, like, not trying to do your homework during class. Like, when you grab these papers, it is not an immediately start working on it. You probably need to know a couple things or learn a couple more things before you're ready to work on it. But some of it's gonna be a challenge, and that's okay. So, in Schoology, if we go to your class, and we go to links, homework help. If you never used this last year, shame on your teacher for not showing you. So we are on homework 5.1.1. Let's say, hypothetically, you struggled on 6C. Anyone struggle on 6C? You're in good company if you did, because I talked with 5 people about that problem. So we can go on to homework help, go to 511. I don't even really have to leave Schoology. Go to problem 6, go to part C, and get a hint. Can 2x plus 15 ever equal 2x minus 15? So let's make up a number for x. Try a positive number, try a negative number, try 0 for all I care. If x is 0, positive 15 equals negative 15? Does positive 15 equal negative 15? No! Guys, we're getting into the difficult math. That symbol means no solution. Positive 15 and negative 15 here create a contradiction. And what that looks like as we get deeper into our more advanced math, if we're doing anything with linear relationships, 2x plus 15, I can model, oh, that's the wrong Desmos, I just want Desmos.com. If you go to Desmos and you go to the graphing calculator that some of you have played with, let's look at 2x minus 15. Oh yeah, that's a slope of 2, a y-intercept of negative 15, right? We talked about this yesterday. I can do y equals if I want to. It doesn't, it knows what I mean is y equals. Now let's do the same thing, but with plus 15. What will changing this to plus do to the line? Its intersection, its y-intercept, will be at positive 15. Since both of these lines have a slope of 2, what could we call those lines? Parallel! So a note you might make on your homework is these lines are parallel and will never cross. All right, so real quick, let me put answers up in front of you, and then we can take whatever like questions you guys. Well, maybe not all of them. We'll see what we have time for. As we switch over to paper homework, now a lot of you got in a good habit with the con stuff. The tricky thing is you're gonna have to hold yourself responsible, because me checking your homework is like I walk around and look like who did it, who didn't do it. You turn in your homework on Friday. Okay, so everybody look here. Then point your eyes there. On the homework board, now that we're on paper homework, I like to collect over the weekend so I have the weekend to grade. So could you turn in 511 like today as soon as you check it? Sure. But what's easier for me? Staple all three of those together and turn them in together. I don't need your homework ahead of time. And honestly, you keeping track of your papers is a skill to learn. And some of you are going to start to realize, oh, this is why we have a math binder. Because by the end of the week, you're going to have multiple homeworks to keep track of, maybe some notes. Schoology has our set of notes. So as another, like, here's your reminder. Right here, system of equations. Anyone go in and actually think to use these last night? I was just curious. Equivalent expressions, solving equations with fractions. That's what we're about to do today. Equal values method. This could have helped you last night on the solving the equations in number 6. Hey, look. Systems with no solutions. Parallel lines. Systems with one solution. This is what you guys are looking for everything to turn into. But guys, sometimes there's infinite solutions. I don't think we've seen any of those yet. But all right, let's look at, keep trying to make, because I wrote all this stuff down so I don't forget anything. When I grade this homework, you will get a grade right here. It'll be a check, or a check plus, or hopefully not a check minus. How that grade gets figured out is the effort you put in. So notice it does not say correctedness or like rightness or like it's not about right answers. It's about engaging with the math and trying it as best as you can. But if you end up with a wrong answer written down, that's okay. This is not the test. This is part of our learning. You know, it's like your rough draft, right? It's okay if it's not all perfect. But I'm going to show you the right answers so you can ask questions if you got them wrong and you're like, no, why? Like, don't just raise your hand and say, I got that wrong, talk about it. Think about it first. See if you can figure out what your mistake was. If you can't, then you want to ask a question about it. If you are about to frantically try to write down answers, don't, because just answers won't get you credit. I got to see work. So if you just quickly try to jot down all these answers, and I'm recording, I know you can go back to the video. At least I would assume that you're smart enough to realize if this is being recorded, I put this on the board, you could go back and see this again. Just answers doesn't get you credit. I know that problems take work, so there should be work accompanying some of our problems. Now, the whole solve for x fraction equal to fraction in number 7. Anyone want to remind us, because I see some people who don't have 7 done. Anyone want to remind us how we can deal with a fraction equal to a like these situations? What are we able to do? And today we're going to talk about another method, but can anyone remind us? Madeline? Yeah, you cross multiplied, right? Let's run to homework help real quick. I am going to open this in a new tab just so it sticks around because my Schoology keeps just changing things. 511, question 7. Hey, look, this has a different way of doing things, but Madeline's way probably also works. They said let's multiply by 16. And then they're going to keep walking. Guys, they go all the way to the answer. Not in all of the problems. But yeah, some of the problems literally go all the way to the answer. Now, I like what Madeline said because you remember what we called that? When you do this? Its nickname was the butterfly method, but you might want to write down a note about this if you didn't do this problem last night. Cross multiplication, friends. Cross multiplication. We can do 10 times x equal to the 16 times 7. And we can solve it out from there. So 10x would be equal to 70 plus 42. I think 112. Yeah? Guys, just break it apart. 70 is 7 times 10 and 7 times 6. So now if I have 10x equal to something, how do I get x by itself? Liddy? Yeah! Divide by 10 on both sides. Cross multiplication. Anyone get mad at number 8 when you went to graph it? Did you figure out how to not be mad but fix it? Does this graph have a scale shown? I need to try to get to a y-intercept of -7, but -7 is not on this graph if I assume a 1-to-1 scale. We don't have to use a 1-to-1 scale. We could use a scale of 2. So what if I made every box worth 2? Well, now, -7, okay, -2, -4, -6, -7 would be right here. What's our slope for this line? 1, right? Because that is essentially 1x plus, I'm going to do -7 instead of -7. So, now a slope of 1 is also equivalent to 2 over 2 or 4 over 4 or anything over itself. So if I go up 2 over 2, up 2 over 2, or up 1 over 1, if I want more dots, I can do every 1. You should get a line that looks something like that. Now, if you change your scale. You can also always grab graph paper. If you don't like the little graph I put on your paper, just get a piece of graph paper. I also have partial pieces of graph paper at the back of the room next to the full pages. There's half pages and quarter pages. So then, any volunteers for how I go to graph this line? What's the 3 telling me? The y-intercept. So let's go to a y-intercept of 3. 1, 2, 3 would be right here. What's the slope of that line? -4. Remember, I'm on a scale of 2. So 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Oh, hey, look at that. 1, 2, 3, 4 over 1. I found my intersection point. It's right here. That's where my 2 lines had intersected. Because that had a point there. This line was through here. Questions? If this stuff is needing to come back to you, that's why we practice. To get it come back to us and get it a little deeper in our memory. All right, so if you just want to see their nicer version of that graph. And then for 9, you could have drawn anything you wanted. But if I think about what 9 is telling me, how many things do I start with? From this equation, how many things do I start with? What's my y-intercept? Sorry, I guess I could have been using cards, but Madeline, thank you for raising your hand. Yeah, we start with 10. How am I changing as I move forward? Somebody not Madeline. Aren't you? And I have an overdue book slip for you, by the way. We subtract 3. So if my first, let's make my life easier. Here's figure 0. There's my 10 squares. 3, 3, 3, 1. My next figure, I lose a row of 3. Right? And I'm making a little robot dude. He's getting shorter. My next figure, right? We're losing 3. That's all it wanted. Draw figures. So actually, this was figure 0, if we're being technical. That's figure 0. So here's figure 1, figure 2. So to draw figure 3, he has no body left. Why couldn't the skeleton go to the dance? Lydia?
Because he didn't have the guts.
Wow, that or he had no body to go with. Get it? No body.
Oh.
All right, I'm going to skip 10 for sake of time. You need graph paper out. So 511 is yours until Friday. Clip it somewhere. Put it away safe. It is yours to keep. If you're not done with it, there's your opportunity to manage your time and figure out when to get done with it, when to come get help from me. Am I collecting Thursday's homework on Friday? No, that would be mean. Now, should you do Thursday's homework on Thursday? Yes. But if you need help on it, if I collect it on Friday and we don't have AO on Friday and we don't have extensions on Friday, that would be rude. So I normally collect like Monday through, well, so then when do you think I'm collecting this Thursday's homework? Next week. Like at some point next week. Sometimes I'll collect like Tuesday, Friday. Sometimes I just do everything on Friday. I want you to write down A here. 2.1x. I'm going to do it with you guys. I want these to get out of the way though, because we're not going to do C and D on this slide. (2.1x). I could say that better if I really cared to. 2 1/10 plus 6/10 equals 17.4. Now we're going to solve for x here, but we're going to be smart about it. There is a brilliant first step that makes everything easier to deal with. And before we think about what that first step would be for A, I want you to look at B. I'm not saying that we necessarily have to do B, but B is 100x plus 250 minus 400. A lot of big numbers. Kind of scary if you ask me. Turn to your neighbor and talk about what, you can put your pencil down for a minute. What could you do to B to make everything easier from the get-go? Remember, you can do anything you want to both sides. Chat about it for like 30 seconds.
How do you divide by negatives again?
Just the same as positive, but switch your sign.
Okay.
All right, whose card jumped out? Chase! What's your thoughts on B?
On B?
Yeah.
We take negative 400 and so we take negative 400 and subtract 250.
You are right, but that's not what I'm looking for. You're right, so don't feel like, but I'm just looking for a different way to start this and make it easier. Will.
Divide by 100 on both sides.
Why?
Because it's 100x.
Because everything can divide by 100, right? Like, these are all real big numbers. If we divide by 100, everything. Now, I get it. That kind of makes a decimal here. But I end up with x plus 2.5 equals negative 4. I feel like those numbers are a decent amount easier to deal with than 100, 250, 400. So this is kind of the reverse over here. This situation's, instead of having big numbers to deal with, we have kind of small numbers like 2.1, 0.6, 17.4. Kyrie's light bulb just turned on. I want you to turn to a neighbor, talk about, and you can go ahead and write out what would be a brilliant first step to make all of A easier to deal with. You're learning new stuff that will help you with tonight's homework. When you try to do last night's homework, and tonight's homework will be more difficult all over again. Let's scooch these out of the way. We'll do this in a minute. But really, we should have A written down. A should be on your paper. A should be on our graph paper. We're not on this paper yet. A should... Bro, why did you put that here? Is there anything...
I didn't know if you like already said
No, this is going to be erased. I've got a big eraser, but...
No, I can just erase it, but it's small.
It's better, trust me. Guys, we're on graph paper right now. As my note on the front slide said, you can just continue the day before's graph paper if you still had space. So you don't always have to start a new piece of graph paper. Okay, I got real excited for a second. Even though it's Kira, I am going to call on you since you had such a moment of like, Kyrie, what could we do up here? Say it louder, but even's the wrong word. But say it louder.
They all become whole numbers if you times them by 10.
Times everything by 10. Because it happens to everything. Some of you keep forgetting it applies to like whatever's over there. So 2.1x times 10. 21x plus 6 equals 174. Now what are we going to do, anybody? Subtract 6, and then what are we going to do? Yeah! Guys, why would we work with decimals when we could just as easily... Now, did we have to do that? No, we didn't have to do that. But in my opinion, it makes it a whole lot easier to deal with, and the numbers are a bit less scary. I got another. We don't have to all the way solve this. I want you guys to talk about C and D. What is that like great first step for C and D here? You can go ahead and do them if you would like. It'd be great to have them written down because this is like very similar to what will be on your homework. Not as complex of an equation in these situations. We got to practice what actually. I'm going to write it down also. Guys, I'm also trying to slow down a little bit and give you guys more time to process things in class. So, like, please do not just sit there and wait for me. I need you trying things on your own. It doesn't matter if you do it wrong. That's the point of practicing. You figure out, oh, that was wrong. Let's not do that again. Did you guys win this week?
Yeah.
That's what I thought. Congrats. Keep it up. You look like, what do? I got 2. What can we do to make life easier? Kira? Nolan. Sorry, we all changed seats. So you used to sit back here, but not anymore because I took this.
Mystery.
We'll give him a chance to pick when he gets back. Rowan, what could I do to both sides for C? That's because it's right. Now, guys, be careful, because there's still a trap door here. This does not become 6, well, okay, it could become 6x, but then that would be 6x over 3. Your 3's either cancel, or they multiply and then divide, which essentially gets you to what you would have had. This just becomes 2x. But the trap is that some people like do the times 3 kind of like twice. They cancel and they apply it to the, like, if you multiply it becomes 6x over 3, which is 2x, equal to 90, right? What do we do now to finish it out? Anybody? Divide by 2. Yeah, you guys know what you're doing. Harrison, what could I do on D to make my life easier?
Subtract 1 from both sides.
Yeah, this is one where, like, all right, we could multiply by 5, but I don't really need to do that yet. So Harrison's saying on this one, we could just go back to kind of our standard process. Now, what is negative 6 minus 1? Negative 7. Be careful with that sign work. Now, what are we going to do to finish this out? Multiply by 5, right? So this one, we didn't really have to do anything crafty, any new strategy. But when you see an equation with multiple fractions, with multiple divisions happening, like 12 here. If you're trying to number your notes, if you care, this is 12. Talk to your neighbor about, is there, hold on, listen to the question though. Is there a way in one move to get rid of both of those denominators? Chat with each other. I'd write this down if I was you. We have a denominator of 3 and a denominator of 5. Is there a way to get rid of both at the same time? When you think you have an idea, try it out. Writing down the original thing is at least a good first step. If I just had a division by 3, how would I get rid of that? Anybody? Yeah. If I just had a division of 5, how would I get rid of that? How can I do both of those at the same time? I heard you guys figuring it out as you went, but like you were asking it like a question. Like, well, what if we try it? Say it like a statement. Let's try, not like what if. Let's try multiply by 15. Because what we're really doing is multiplying by 3 and multiplying by 5. Now here I am going to write this out a little bit more slowly. This would become (15x over 3) plus 15x over 5. Not plus, I keep doing that. Equals, oh, I used to know 15 times 15.
16.
I know, but then I could just add another 15. I think 15 times 15 is 225. So 240? Yeah? That's my victory for today. Guys, you should practice math facts in your head just for the sheer pride.
Okay.
All right, so now you could have jumped past this step, but I wouldn't suggest it as we are learning this. But what's happening is 15 over 3, right? Because really this is over 1. But 15 over 3 reduces out to 5x. 15 over 5 reduces out to 3x. And we have our 240. You know what's 10 less than that, right? Time to go to the dentist.
230.
230.
230. 230. You should probably go to the dentist.
Yeah,
Yeah,
230.
230. How do I get back to just x? Divide by 8. See, you guys know what to do once we get to this step. We're just applying one little more layer on top of what we've learned. So I want you to try to do the one on your paper. Now, I worry that some of you immediately started writing on here. If you need a big eraser, I already let Carter use mine. We can pass it around. But on our paper, we're going to fill in what we did. We'll probably come back to that. I'm just going to pull my paper under the dot cam. Yo, so here's what we're gonna put here of what we did, the explanation. I don't know why some of you were writing the first couple problems we did here. These are gonna be words that we write in, friends. So this 6, what really is that? When we look at 3 and 2 and 6 and we decide we're gonna multiply by 6 on both sides, what is that? Harrison? So, it's the what denominator?
The sums denominator?
Close. It's the lowest common denominator, right? So, we're going to multiply by the lowest common denominator. Here we got lucky. 6 is our lowest common between the 3 and the 2. So then for B, this is really what did they make sure we thought through? To everything. The trap door is you'll forget to do the second multiplication. This right here is what people forget to do. And I'm hoping that you don't forget that. What I'm telling you is what I've seen in the past. So now, what did we really do in C? How could we define? They put these numbers together and made them simpler. Yeah, we simplified. We reduced, right? So reduce / simplify. And then what did they combine? Yep. Sorry, that's an N. That definitely looks like an H now, though, but that's an N. Combine like terms and solve. Do that whole on both sides stuff to solve. Our OBS stuff are on both sides. Caroline, is that a hand or are you just holding up the wall? Okay. I appreciate that. So let's try a couple more. And here's what I love about paper homework. There's no wasted time logging into your computer. But I need you to resist the temptation to just start working on your paper homework right now. Let's practice this a couple more times. I'll give you the last 5 minutes to work. Let's write down, let's do A and D. Let's do A and D, just for fun. Let's do A and D here. Sure, throw it. We'll see if overhand throw. Come on, man. You got an underhand to arc it up and give me more time.
You wouldn't want to hit Kyrie.
Okay.
I mean, I would.
So, Arnya. Hey. Work out these issues outside of school. Arnya, with A, what is your thought of that? By the way, guys, the nickname for this is Fraction Busters. It's one of those CPM nicknames like Giant 1 and things like that. But what is our technique for busting the fractions here? Yeah, 21 would be that least common denominator. So now, if you want to skip over this step and reduce in your head, that's risky, but you can. I'm going to write it out. This becomes 21a over 7, 21a over 3, 210. So then it becomes 3a, 7a, 210. This feels much nicer to solve. 3a plus 7a? How do I get back to just 1a?
Divide by 10 on the sides.
The original. A equals 21. Try D on your own. Then we're done for today. Try D on your own. What's our common multiplier? But be careful. Notice those numerators are a bit trickier. Try D. The numerators are a bit trickier. Man, 3, 4, and 5? You guys know I know it. I'm waiting for your brains to think through it. 5, 10, 15, 20, 25, 30, no. 35, 40, no. 45, 50, no. 55, 60.
3 times 4 is 12.
It's 60, friends. We gotta go all the way up to 60.
Oh my god.
Hey, if you aren't writing this down, you're not giving yourself the opportunity to mess up. Now, I will show you how we can, like, shortcut to the reducing. Give me your eyes up here if you want. You could, like I did last time, 21a over 7, 21a over 3, like, or go ahead and think about what is 60 over 3. Like, what's 60 divided by 3? 20. What's really happening here is 20 times b plus 3, which is going to give me 20b plus 60. What is 60? Why didn't you change the? What is 60 over 4? 15. So that's really 15 times b. And don't forget that minus. And what is running out of unique colors? 60 over 5. 12, so that's really going to turn into 12 times b minus 2. So 12b minus 24. Yeah, that's about as difficult of a problem as we're going to see right now, and probably not even to that level unless we're working together. But if I keep simplifying, because I want to give you guys a couple minutes to work on your own, 20b, negative 15b, 5b. My 60 doesn't have anyone to join up with right now. 12b minus 24. I know you guys probably think at this point you don't need my help, but here's one more tip. I have said all year long, put your variables on the left side. Variables are better on the left side. Here, I disagree. Anyone want to tell me why I think the right side should be our variable side here? Which side has the bigger variable? The right side. So when I'm putting variables together, I'm either going to subtract 12b from both sides and end up with a negative, or subtract 5b and end up with a positive. It's your choice. Algebra gives you the freedom to do whatever you want. But if we do this, we keep positive, and you gotta stay positive. That's what life is all about. So my 7b, it's positive. How do I get rid of that minus 24? Add 24 to both sides, and then we can divide to solve. But we don't need to finish that. You got the last. There's only a couple minutes left, but I know some of you have been sneaking some homework work already. Please make sure your names are on these homeworks, so when I find them laying around the building with one problem done, I know who to get it back to. Please make sure your name is on your homework. Bro. If you want to think through one kind of similarly difficult, go ahead and jump yourself to B. Between 2, 3, and 9, we're going to have to do a little bit of work to find the common denominator, but it's not as bad as getting all the way to 60. That's why I wanted us to talk about that one together. Guys, these problems are going to take some work written out. That's why your grade is an effort grade. In 22, let's call that one a pick 2. You get to choose which ones you want to do. In 22, let's call that a pick 2. Okay? You're welcome. I just reduced your homework by 2 problems, essentially. All right, head to lunch. Have a great day.